Welcome to another video of this course about checking fixtures. So in this video we will be discussing about the different types of checking fixtures in particular. So we have already discussed what are these checking fixtures, what is their purpose, that is what we expect from these checking fixtures, and then we also discuss the areas of their application where these fixtures are used. So let's look into the types. So in this video we will start with an introduction, then we will talk about the inspection fixture, which is the first type of fixture. Then we have the welding fixture, assembly fixture and conventional fixture. So we will be discussing about all these different types of fixtures, but first we will start with the introduction. Now the basic idea behind the use of checking fixtures is to restrict the motion of the part using clamps or pins or by any other means. So that is understandable when you are working on a part. Okay, let's say you want to drill a hole here. Okay, and let's say you are drilling it with a drilling gun. Okay, or a drill, you can say a power drill or a handheld drill. So what you do is you press your hand against this workpiece, so this block, okay, and then you drill it, okay, so that it doesn't move along and the drill is at the exact location where you want the hole to be. So the similar thing happens with our mass production. Let's say any product or our vehicle is being produced, or the vehicle body is being produced. It is through mass production, that is the n number of products are being manufactured alongside in a production line, and we will be needing to machine, cut or drill holes or any of these features, and for that we want the part to be fixed. So whatever mechanism you use or whatever means we use to hold any of the workpiece together or any of the part together so that it doesn't move and remain stationary, okay, we call it a fixture. So this is the basic idea behind the checking fixtures or fixtures. Based upon what the fixture is used for, we can have different types of fixture. Now we can classify the fixtures depending upon either the purpose they serve or the application, like what are they used for and all of these features. So there can be many different ways, but we will be classifying them depending upon the simple use, that is what are they used for. So looking at it from this perspective, the checking fixtures is divided into the inspection fixture, which is used for checking the part or in running the inspection of the part. And then there is a welding fixture, assembly fixture and conventional fixture. So like I said, inspection fixtures are used to hold the part at a stationary position, okay, so that you can move it around. As you saw in the previous video, the fixture had handles, so you can also move it around. And basically if you use a fixture for the checking or inspection, it is called an inspection fixture. Also if you want to hold a part at a stationary position so that it can be welded, we call it a welding fixture. And an assembly fixture is basically to check any part for the assembly purpose so that it fit in a specified location or not. Then we have some conventional fixture, which consists of all the fixtures that are not included in these three, that is inspection, welding and assembly. Or you can say these conventional fixtures are used for the machining purposes or removing of a material. So we will be discussing about these three now. So the first kind is the inspection fixture. Now inspection is a routine component of the manufacturing process. As parts comes off of the production line, some are examined to ensure accurate dimensions. This process requires specialized work holding, and thus the fixtures which are used for this purpose, that is holding the work part for the finished component at a fixed location, is called an inspection fixture. So like I said, everything is mass produced. Okay, they are just a component and component being produced like one after the another. Let's consider this hood. This is a hood of the car, or the frame, or the sheet for the hood of the car. It will be welded on to the body chassis or the frame of the car body. So this is done by cutting it from the sheet metal and then forming it in this required shape. So the press would just go up and down, and the material or the sheet will be unrolled. This sheet comes in the form of a big giant heavy roll of stainless steel or steel, and it is just unrolled and it is fed into this stamping machine, and it will keep on producing these n number of products. So this is what a mass production is basically. Okay, so one after the product, one after the other, all these hood components are coming out, but you need a proper tolerance and accuracy. Okay, so you just like from one batch we take out this and we fix it on these toggle clamps. So there are 4 clamps here, so they will hold it, and this is basically the frame, or you can say the base of this fixture. So it will hold it on to this part. Okay, so this is what a fixture is, and you know that inspection is very important to maintain the quality and a fixed standard. Now this can be done using either manually or by using a coordinate measuring machine or CMM machine, which is a precision tool that probes multiple points on a part to determine if the geometry is within the specifications. Check gauges are another form of inspection fixture used to quickly and accurately determine if the parts are satisfying the basic tolerances. Now if the part is fit into the gauge, the part is within the specification. So these gauges are basically a go and no go type, or you can say like a vernier caliper, or usually a device which is like something like this with a needle here and a screen here which displays the tolerance. It will just give you the measure of the surface. You just place it at these locations. Okay, so the tolerance will be mentioned on this screen. Now in order to properly fix or hold the item or the product, we need to inspect. Precisely made pin or clamps are used to locate and hold the part and log 6 degrees of freedom. So every component have 6 degrees of freedom. By degree of freedom, you know that a degree of freedom is basically the number of variables which can determine the position of any part. So any part can be in Cartesian system. Let's say this is a cube, and every Cartesian system has 3 axes, the x, y and z. So this cube can be translated along y, along z or along x, or it can be rotated along this axis, along the x-axis and along the y-axis. So in total we have 12 degrees of freedom, or 6 degrees of freedom if you consider only one direction, like 12 degrees. When I say 12 degrees, I mean that positive y and negative y, positive z, negative z. So like this you can say 12, but here you can only say 6. That is translation along y, translation along z, and translation along x-axis, and rotation along y, rotation along z, and rotation along x-axis. So we have 6 degrees of freedom. So these fixtures or checking fixtures should be able to restrict all these degrees of freedom so that the part remains stationary or stable. Okay, so this was all about these inspection fixtures which I used to check the part and its tolerances. Okay, moving on with the welding fixture. So now in every production process where welding or robotics welding is necessary, very high quality accurate welding fixtures determine the quality of the final product. A welding fixture is used to position the product parts for welding, and this secures the geometry for the products. So basically what I mean to say is with the increasing technology, the quality of the product that we are getting is increasing, and we can do very precise machining, and the same thing goes for welding also. So the parts and the components are to be precisely welded, and for that purpose they need to be held together, okay, so that there is no variance or any uncertainty in the final product. So for that we need to hold these two parts together, which are to be welded using any type of welding technique. So for that purpose the fixture which are used are called welding fixtures. To be able to accurately position your product part, both the product and the welding options are to be considered, okay. So it is not like you can only make changes onto the fixture. It cannot be done. Some changes might be needed to be made on the product surface as well, as a feature which can later be removed or be integrated into the design of the product. Like sometimes it is necessary to integrate a specific functionality on the product before it is welded, which will allow the part to help fix it as desired on the welding fixture. Other considerations also play a role, like construction possibilities, the number of products, ergonomic options in view of ease of use, or the expected cost of various options. This is obvious. We need to be very under the specific budget. We cannot go budget like every project, or have a specific budget or a limit to the how much we can spend on it. And the same goes for the fixture as well. So the better the quality we want, the higher will be the cost. So when you look at these images here, you can say these toggle clamps and the product is just held on this fixture. And now this is a robotic welding, like the welding is done by the means of this robotic arm. This hole is actually a part of the fixture here, so it can be rotated in any direction depending upon how this robot or the machine wants it to move. And they are fixed, the multiple product, as you can see, are fixed using these toggle clamps onto these base plates here. So this is our typical welding fixture. Again, here also we have a welding fixture. The base plate is mounted through these nuts, and then we have a clamp holding it down. So this is what a welding fixture is. It basically holds down the part and for the welding purposes, or basically like when you want to say I want to weld these two components together, let's say they are cylindrical pipes, and if you want to weld them together, they have, let's say they are made up of stainless steel, and stainless steel has very minimum thickness, so there is very minimum margin for the error. So for these two parts to be held on edge to edge for a proper welding is very necessary, and that is why we need these fixtures or welding fixtures to be specific. So this was all about the welding fixture. We have the fourth type, that is the assembly fixture. Now, as the name clearly suggests, that the assembly fixture is used to locate a different spot welded or nut bolt joint part together for checking their interchangeability and positioning. So in simple terms, like you can see this, it is a car chassis or a body, and it has several n number of components which are simply bolted together through the means of nut bolts or spot welded together by the means of robotic welding. Okay, now the welding technique is not under consideration. Okay, so the assembly fixtures are simply there to check if these components will assemble or will fit into the desired location without any problem or without interfering with the environment area. Like let's say this component should be able to fit exactly within this boundary. Okay, so for this we can fix them using these fixtures and check if they serve the purpose or if there is any error that is needed. So you can see here, this is the environment or like the rest of the part, and this is a complete panel of the back side of the vehicle or the trunk, you can say the trunk door. And if we want to fix it, it is usually done by spot welding. So this is the replica of the rest of the component. So this simply denotes the area or the environment where this needs to be fixed. So using these fixtures we can fix them here and check if there is any error or any interference at any location. Now unlike the other types of fixtures, like surface or the profile is not of importance, that is we are not checking how the profile or the finish is here, okay, rather how the part will fit into its desired location is the major consideration. So moving on to this image, let's have a look. Again, this is an entirely different fixture here. This is a assembly fixture, and again this is, you can see, it is a door panel, plastic component, door panel of the vehicle, and again it needs to be fixed onto the door frame or the car body, and there also it has some tolerance that it need to follow, that there are other surrounding environment, surrounding parts also. So like this is the door panel and this is the B pillar in center, so the panel needs to be fixed here like this. So all the its boundary should not be variable, like it should be matching with the boundary or the frame of the vehicle, and also here it needs to have a proper clearance between this B pillar and this panel itself. So here, as you can see, we fix this door panel onto this fixture here, okay, and then we fix it using all these clamps. And then here you can see it is the same measuring device which checks the tolerance. It will insert it at these specified points here, and it will display the value on this small screen. So with this we can check whether these edges are under the required tolerance or not. So, and this is just to check if the door panel will fit in its desired location. Now similarly, in this image, as you can see, there will be a light bulb here, or the bulb here, the back light, you can say, the whole casing, along with the whole casing. So we need it to be very precise so that it fits in this slot, okay. And for that, again, we will be using an assembly fixture. Like the fixture there will represent this slot here, this socket, and the actual part or the casing will be fixed here, just to check the tolerances or whether it will fit or not. So just to check the assembly of these two components, or the feasibility of assembly of two components or many other components, we use an assembly fixture. Okay, now lastly we have the conventional fixture. Now this is a broad category of fixture which consists of all the different fixtures serving the purpose of holding down the workpiece for different types of machining operations. So machining is basically removing of the material from a part. So like I said, you basically need to hold down the part so that you can perform any desired operations on it. So this serves the same purpose, and all the fixtures that doesn't come into the previous three categories are placed in this conventional fixture category. Now we have different types of conventional fixtures as well, like this milling fixture. Now you all know that milling is basically the material removal process which is done by a rotating blade or a rotating bit, which removes material either in vertical direction to create a hole or along the horizontal direction, just like this. So you can move it along this, so that the sides of this blade, that is, this is the cutting blade here, so the sides of this blade can be used as well to remove material horizontally and also to drill a hole. So this is the basic difference between drilling. If you ever get confused about drilling and milling, so drilling, you can only create vertical holes, okay, in the vertical direction you can only create simple holes, but milling on the other hand can be used to create hole as well, just like drilling. In fact, most of the milling machines, you can fit your drilling bits to create the hole as well. But in milling you can run the blade in horizontal direction or use the sides of this blade to remove material. So this is the basic difference between a milling and drilling operation. And a milling fixture is just like this. So this is basically the milling fixture here, and these are the part of the workpiece which are to be machined. And again you can see it can either rotate it along this axis or move this fixture to change this position, and this fixture are holding these part down and are not allowing it to move while this blade is removing the material, or this milling machine is removing the material to create the desired profile. Next we have the boring fixtures, which look something like this. Boring is simply the if you want to increase the diameter of a previously drilled hole, and the process that is used is called boring. So boring is a simple process of increasing the diameter or removing more material from a hole to increase its diameter, and that is only done by rotating. And these are the some of the fixtures which are used to hold these part together while it is fixed onto a chuck, or you can say a milling machine or a lathe machine, and the boring can be done. And finally this is machining fixtures. Now the machining is simply the removing of the material. So like this is the part of the casing here, and we need to machine the entire thing, and these are the fixtures, although this is complete fixture that is used for this purpose. So this is a simple machining fixtures, and all these come under the conventional fixture types. So these are all of the 5 different types of fixtures that we use.